Up here are 3 problems, and it says to simplify. So simplify just means to cancel as much as you can. So like if you had the fraction 3 over 6, you would simplify that to be 1 over 2 because they would both have a common factor of 3 in the numerator and the denominator. This is the same thing, but the factors are much more complicated. Okay? So while you guys are copying some of that down, some notes about what you cannot do. If I had something like this, can I cancel out the x squareds? No. Okay? There might be something I can do with them later, but here's the thing. You can only cancel out factors. So a reminder of what a factor is. I told you guys that you guys would reduce 3 over 6 to 1 over 2. That's because technically you could think of 3 as just 1 times 3 and 6 as 2 times 3. And so what you're saying is the numerator is this times this, not plus, not minus, times, right? So it has to be the things that are being multiplied together, and you just have to have groups of things multiplying each other across the numerator and denominator. Then you can cancel out ones that are common as long as it's the entire thing and it's multiplying everything else in the polynomial, not added or subtracted. Mikey? No. Okay? So here's the general idea. We can't cancel anything from either of these right now because these aren't factors. This is one giant factor right now because it's not multiplying with anything else. And in that factor, there are 3 terms. So terms are what we call the things that are being added and subtracted together. You can't cancel out terms, right? You cancel out common factors, which means you have to rewrite the problem as something multiplying something multiplying something, and you don't want anything being added onto that at the end. Inside the factors, you can have stuff being added or subtracted, but that stuff is part of just one factor. Okay, so for example, if I did factor this, okay, this numerator, x squared plus 2x plus 1, actually factors to x plus 1 times x plus 1. And this denominator, x squared minus 1, factors to x plus 1 times x minus 1. Notice that now there are multiple factors in the numerator, right? So factor, factor, and in the denominator there are multiple factors as well, okay? And I almost wish like I had I would never call this like x and then a plus 1 is like x plus 1. It's like one package, okay? You cannot cancel the x, you cannot cancel the plus 1. You can only cancel another entire factor of x plus 1. Okay, so these could cancel because this entire factor that's multiplying the rest of the stuff in the numerator cancels this entire factor that's multiplying the rest of the stuff in the denominator. I'm not canceling out anything that's being added or subtracted with something else. Does that make sense to you guys? Okay, so you have to see those groups as one entire package, and you can only cancel them if you have written it in a way that everything is multiplying each other. Okay, all right, so now that we've clarified that, I'm going to erase this stuff. And so when we look at the first one up here, so all of these are either just written as a fraction or a multiplication or a division problem, because those all work the same way like with fractions, right? If you can find any common factor, numerator and denominator, you can cancel them out, whether you're multiplying 2 things together or you just have one. So in the first problem, it's almost completely factored, except for the x squared minus 4 that's in the denominator. You could factor further. And you do want to look at it. Some of you are at a place where you're like, I know I don't have to factor that because it doesn't cancel with anything else. And that's fine. But for those of you that aren't at that place, you really want to write everything in its most factored form so you can see what can cancel. So in this problem, what can cancel? X plus 1. Now, I see lots of 2's, and then I see lots of x's. Can anything else up here cancel? No. Okay? Because this is just a factor of 2. There is nothing else in the denominator that is just a factor of 2. There are 2's being added or subtracted with something else that are part of a bigger factor, but there aren't any just factors of 2. Okay? So my final answer, the most simplified form of this, is what I have here. And you can choose whether or not to multiply back out the denominator to get x squared minus 4. Personally, just from like a math student perspective, why multiply it back out? I might make a mistake, right? Or I have to do extra work and it takes extra time, so I just leave it in its factored form. Okay? So I would have that. Right, so what do we have to do in part B? Good. Factor before we cancel. Right now, there's one big factor in the numerator and one big factor in the denominator. They don't match, so you can't cancel out their entire thing, and you're not allowed to cancel out pieces of them. So if we go to factor the numerator, it factors as x plus 4 times x minus 2. And I'm assuming, based on the fact we've reviewed this in this class before, and you've had Algebra 2 and you've had Algebra 1, that you can factor. If you can't factor, you could see that this unit could be a struggle. So you should come in at a tutorial or a tutoring time so that we can brush up on how to factor properly, because we're going to be using this at the beginning of each of the problems that we do. Okay? And then in the denominator, it factors as x plus 3 times x plus 1. So what can factor in this rational expression, or what can cancel? Nothing. Good. And is that okay? Yeah, and you just have to be okay with that. Can't be like, well, I'm going to just cancel these part of these x's so that something cancels. No. Okay, the whole factor cancels or nothing cancels, so in this case, nothing, and that's the best I can do. And whether you kept it like that or wrote it like that, those are the same thing, and that's fine. Okay? All right, so the last one is a division problem, okay? But remember that a division problem is really just a multiplication problem, right? Your algorithm for dividing fractions is that you take the first fraction, and it being divided by the second fraction is the same thing as it being multiplied by the reciprocal. And then remember how you multiply fractions. Having something like this is the same as having something like this. This is basically one big fraction with all these factors in the numerator and all these factors in the denominator, because with fractions you multiply straight across the numerator and straight across the denominator. So then we can go ahead and factor whatever we need to factor here. So this first numerator, that's factored. Okay, y plus 2 is one factor, kind of in that package. You can just say. And then in the denominator, these have a common factor of y. So the denominator of that first fraction would factor as y times y plus 5. The denominator of the second fraction is already factored. And the numerator would factor as y minus 5 and y plus 5. All right, so what can cancel based on what you're looking at here with this multiplication problem? Okay, yeah, so y plus 5 can cancel. Anything else? No, right? It's so tempting, right? You see factors of y, you see things with y and 2, but none of them match completely. So you just have kind of this complicated thing going on. In the numerator, you have y plus 2 and y minus 5. And in the denominator, since there are two single factors of y, they would write it as y squared and then y minus 2. You can multiply all that stuff out further if you want, but you don't need to. So you can save yourself time and the possibility of making an error by just leaving it like this. Yeah, Matt? Okay, but it won't be y plus 2. Good idea. And there are times that we do that when they're in reverse order. But if you pull a negative out, you'll actually have negative y plus 2, so it still won't match that one. But that's actually a good point. There are sometimes, maybe you have, make sure I write this right. Sometimes you'll get something like this, okay? So your first step should be to rewrite this denominator in the order you would want it in, which is variable first, constant second. So the a is negative and the 2 is negative, so I would rewrite it as negative a minus 2. Then if I pulled a negative 1 out of that denominator, I would see that those cancel. And so really all I would have left here, is negative 1. So it's definitely an idea and a thing that we've used before. It just wouldn't work in this situation because the y would then be negative. Okay. Any other questions about simplifying these? No? Okay. So all of this works for if you're just given a fraction, you're given a multiplication problem, or you're given a division problem. Okay? But the other thing you have to be able to do is to add and subtract. So when I think adding and subtracting fractions is harder than multiplying and dividing them. Okay? So Why is that my opinion, do you think? Yeah, because you got to have the common denominators, right? You don't add a 6 and a third just like automatically. You say, well, let's make them something common so I understand how big they are in relationship to each other and can actually add them together. So you still have to factor the denominators here. And then you have to decide what the common denominator is going to be, okay? So what is the common denominator going to be in this case? So remember, when you're picking common denominators, you're not eliminating anything from the denominator. All you can do is multiply new stuff in until you can get them to be the same. So like this denominator already has an x plus 3 and an x plus 2. So whatever I choose as my common denominator is going to have an x plus 3 and an x plus 2. Okay? But then when I look at the next denominator, it has two x plus 2s. I already have an x plus 2 as part of what I'm saying is going to be my common denominator, but I don't have two of them, so I need to put in another one so that there would be two of them. Okay? So in the end, I need these two fractions to have this denominator with these three different factors in it. Okay? So this first fraction already has two of the factors, but then it needs another factor of x plus 2, and whatever I multiply into the denominator, I would have to also multiply into the numerator. The other fraction has the two factors of x plus 2, but doesn't have any factor of x plus 3 and needs one of those if it's going to make this common denominator. So I need to multiply into the denominator a factor of x plus 3. Then I have to do that in the numerator also so I don't change the problem. Right, so see now how the denominators match? So you're okay at that point to make one fraction because you have one common denominator. It has all these factors in it. But there's still going to be a bunch of work for you to do in the numerator because the numerator needs to have this happen plus this. It means you're going to have to distribute and combine different like terms. Okay? So here, if I distribute this, this is like x squared plus 2x. I have a plus sign, which is nice. If it's a minus sign, it gets a little more difficult because you have to distribute that, if necessary, afterwards as well. And then here we have a 2x plus 6. So in the numerator, these two combine together. So we have x squared plus 4x plus 6. And in the denominator, these three factors. And you could write x plus 2 squared if you don't want to write out the two factors. So now that you've done the addition, it still becomes a problem like you saw on the last slide. It's still a simplifying problem. So you have to ask yourself, does this factor, and if it does, do any of those factors then cancel with these to make a simpler answer? So the first question, does this factor? Okay. Are there two numbers that multiply to make 6 and add to make 4? No. Then it's not going to factor. Okay? And so then, since it doesn't factor, there's no way it's going to cancel any of those other factors down there. So then that's it. Okay, but we have to check because there might be a simpler form depending on the answer. Right. So rather than me do the next two, but I need you guys to practice a little bit with addition and subtraction. In your groups, work on this subtraction problem and that addition problem. Okay, and then we'll have people put up the answers for us to make sure that you can do. All right, so first one, we want to factor the denominator so we can look for the common denominator. So in the first fraction, 2 is a common factor, and we factor that out and get 2 times x minus 3. And then in the second fraction in this subtraction problem, 4 is a common factor. Let me get this. Okay, so when I'm deciding what my common denominator is going to be, again, I'm looking for the least common denominator. Okay, when I look at the first fraction, my denominator is going to have to contain a factor of 2 and a factor of x minus 3. Okay? When I look at the second fraction, it needs a factor of 4 and a factor of x minus 3. So I already see the x minus 3. There isn't a factor of 4 here, but 4 breaks down to be two factors of 2, and this already has one factor of 2. So all I need is another factor of 2, okay, which means my common denominator that I can make in both fractions is 4 times x minus 3. Now, if you got a different denominator, that's fine if it was something like 8 times x minus 3 or something like that. But if you start multiplying in too much stuff, your numbers are going to get really large, and then you have a lot more simplification to do at the end, so it's easier to keep the least common denominator, okay? So if this is my least common denominator, the second fraction of the problem already has that and doesn't need to be changed. The first fraction is missing a factor of 2 in that denominator, and that also has to happen in the numerator, okay? So now both fractions have this denominator of 4 times x minus 3. So they can be made into one fraction. But again, this one fraction has all this work. This, okay? So think about what that means. You have 2 times x minus 5, and you're subtracting this entire thing, which means it should be in parentheses after that. Okay? So in the numerator, we're going to have 2x minus 10 when we distribute the 2. And then we're going to have negative x plus 7 when we distribute this. Our denominator hasn't changed. And then I want to finish all my addition and subtraction and combine all the like terms in my numerator. And then the last thing I'll do is then see, can it factor and cancel with something else? But I don't do that until I've combined everything together. So 2x minus x is x. Negative 10 plus 7 is negative 3. So the numerator cannot be factored any further. Are there any factors that can cancel between the numerator and denominator? Yeah, right? The x minus 3. Okay. So when you cancel out this x minus 3 in the numerator and there's nothing left, what factor is really left there? 1, because this really could have been multiplying a 1 and no one would have seen it. So your solution here, or the simplified version of this problem, is 1/4. Okay? All right, in the second problem, we're going to kind of use what Matt was talking about earlier. Second one there. Okay, so again, the first thing we want to do is we want to factor and simplify the denominators. So for the first denominator, you use the x or guess and check or whatever you do to factor, and you end up with 2a minus 1 times 2a minus 1. In the second denominator, if you want to factor it and you want to see if there's already common stuff, you want it written the way that these ones are written, meaning you want the a part first and the constant part second. Right? So instead of thinking of it as 1 minus 2a, I would rather think of it as negative 2a plus 1. Okay? But does negative 2a plus 1 match anything that I have over here? Not really, but if I pull that front negative out of there to try and make it look like those others, if I pull out a negative 1, I get a positive 2a and then a minus 1, okay? So this is like having a negative 1 times a positive 2a minus 1. Now, when you guys get something here that's just changing a negative, you can make it part of your common denominator, but it gets a little confusing as far as what it multiplies through. So my advice to you would be, we can just take this and actually distribute through the negative 1 part, right? So I can actually just take the negative 1 and to cancel that out, distribute a negative through the terms of the numerator, which would make this negative 1 and then positive a. Is that okay with everybody? Then you don't have to deal with, like, is this negative? Is it not negative? When you're making the common denominator. All right, so when I do make a common denominator in this problem, when I look at the first fraction, it needs to have 2 factors of 2a minus 1. So that needs to be in my common denominator. When I look at the second fraction, it has 1 factor of 2a minus 1. That's already been covered by the fact that the first fraction needed both of these. Okay? So to make the common denominator, it's only the second fraction that needs factors put into the denominator. And so we need to put in an extra factor of 2a minus 1. Numerator and denominator. Okay. So again, now both of these fractions are going to have a denominator that has both factors of 2a minus 1. Okay. And in the numerator, I'm going to have this plus all of this that's happening over here. Okay? So I basically have 1 plus, and what's happening over there is that there was a negative 1 plus a that is now multiplying a 2a minus 1. So you cannot start canceling. I know it's really tempting. It looks like you can, right? Like, oh, factors. But this is not a factor of the numerator. It would be if this part wasn't written here. But the fact that this might be multiplying other stuff but then is added with something else, it's not a factor yet. So we have to multiply this all out, combine all this stuff together, and then see if it factors once all of that has been done. Okay? So to multiply this out, so I want to distribute, so I'm going to get negative 2a, positive 1, and then when I distribute the a, I'm going to get plus 2a squared and minus a. So in my numerator, I'm going to try and clean it up a little bit. I have a 1 plus, and then I have all these terms right here. So I'm going to try and write it in the order we would be used to seeing it, so like highest power to lowest power. So there's one term that has a squared in it, so 2a squared. Then for the a's, there's a negative a and a negative 2a. So when I combine those together, I'll have negative 3a. And then for the constants, there's this 1, and then it's being added with the constant of 1 from this multiplication. So 1 plus 1 give me 2. And my denominator is still this. Now the addition is done, and now the question is this the most simplified form? So you're really asking yourself, does this numerator factor? If the answer is yes, factor it and check and see if any of those cancel with the factors below. Okay? So to check if this factors, 2 times 2 is 4. Is there two numbers that multiply to make 4 and add up to make negative 3? No? So there's no two numbers that multiply to make positive. What's that? So if we used 4 and 1, we have to make one of them negative 4, but then they multiply to make negative 4, not positive 4. Does that make sense to everybody? Okay. So you're off by a negative. So you guys were right the first time. There's nothing that works, right? Close, but no. Because 2 and 2 and 1 and 4 are your only options. If you use 2 and 2, they won't add up to negative 3 in any way. If we use 4 and 1, this is how we can get them to add up to negative 3. But then they don't multiply to make positive 4. They multiply to make negative 4, and that's not going to work. Okay? Which means this can't be factored, so it can't be simplified, and that's the best that we can do. All right, are we remembering some of this stuff? So. A little scary. Okay, because there's one other thing you have to be able to do. I know. All right, so everything you've done so far is in the world of simplifying. Were we solving anything? Did we say at the end a equals 5 or x equals 10? No. This was all simplifying. Put it together as much as you can, factor out as much as you can, that kind of stuff. The other thing you have to be able to do with this stuff is solve. Okay? This looks like an addition problem. But what's the difference? Well, there's also numbers. Yeah, Coletta? Good. It's equal to something. If this was a problem like we just saw, we were just simplifying, we wouldn't have equals this fraction at the end. We're actually going to do this a lot like the last problem, but let me remind you guys, when we were solving some stuff earlier in the year, and maybe we had something like this, and you guys didn't want to add and subtract fractions, what did you do to this problem so that it didn't have any fractions and you could finish solving it without the fractions? What is something I could do to this equation so that in the next step it would no longer have fractions and that I could finish solving it? What's that? I just didn't hear you. Yeah, times by 10. Is it okay if I times everything by 10? Right? Okay. You can multiply both sides of an equation by whatever you want. Why did Matt choose 10? No, not because he likes 10. Because 2 and 5, that would be their least common denominator. So you know how we just worked to find least common denominators when we were adding together? We're still going to find the least common denominator, but this time we're going to do this with it. We're just going to multiply everything by it so that it cancels out a bunch of stuff, and we have a problem that doesn't have fractions anymore. Okay? So when we look at this problem and we look at the denominator, the first one can't be factored. The second one is a number, has some factors, but we don't need to factor it. The third one can be factored. Okay? What is the least common denominator? If you were trying to add all of these together, what would you pick as the common denominator for every fraction to have? So according to the first one, we need a factor of y plus 2. Okay. According to the second one, we need a factor of 15. And according to the third fraction, we need a factor of y plus 2. It's already accounted for. And we need a factor of 3. Do I need to put a factor of 3 in here? No, because 15 is 3 times 5, so the 3 is already in there, right? Okay. All right, so this is the least common denominator, but I'm not going to make new denominators. I am going to multiply this entire equation, both sides of it, by what I would normally make the and the y plus 2. Okay. So how does that help me? When this quantity goes and multiplies the term of the equation, so in other words, this fraction gets multiplied by the 15 and the y plus 2. The y plus 2 cancels out, okay? And I'm left with 3 times 15, which is 45. Okay? Then I take that whole quantity and I multiply it times the second fraction in the problem, okay? So now 7 over 15 is going to get multiplied by 15 times y plus 2. So here, the 15s are going to cancel, and I'm going to be left with 7 times y plus 2. You can distribute it now or later, okay? Then it's going to go to the other side of the equation and multiply this fraction. Okay? So when 23 over 3 times y plus 2 multiplies with 15 times y plus 2, the y plus 2's cancel. The 3 goes into 15 5 times, and I'm left with 23 times 5. It's 115. Is this a lot simpler to solve than this? Yes. Okay? So I'm picking the common denominator the same way I picked it when I did addition, but am I making everything have a denominator here? No. When I'm solving, because I have an equation with 2 sides, I can start multiplying by whatever I want as long as I do it on both sides. So I'm going to multiply by the thing that's going to cancel out all the denominators. Okay? So now I just need to solve this. So this is 45 plus 7y plus 14. And I can add together the 45 and the 14, and that makes 59. And then I can subtract 59 from both sides. Well, 70 is too big. 66, right? Okay. And then I'm going to get that y is equal to 66 over 7.
It's 56.
Oh, 56. Sorry. 56 over 7, which is 8. Okay, so I have an answer. Now, notice I put a little check thing up in the corner. The reason I said to check is this. Sometimes in these problems, because you get rid of the fractions, you come up with an answer and you did nothing wrong, but the answer cannot actually be. In this case, 8 is fine. Looking at this problem, what's the only y value that would make this problem not work or have things be undefined? What's a y value that if you tried to plug it into these fractions, it would make stuff you couldn't calculate in the original problem? So here's y. What could you possibly put in here that would make this quantity not able to be calculated? -2, right? Because -2 plus 2 would be 0. And do you know what 3 divided by 0 is? No. 3 divided by 0 is not defined. Because anything divided by 0, think about it like elementary school stuff. 3 divided by 0, you're trying to think what number times 0 makes 3. Will you ever come up with an answer in our number system? No. So dividing by 0 makes stuff undefined. So the only thing you guys have to watch out for is check at the end that your answer is not the same number that would make this undefined, because that won't work. Okay? So is 8 the number that would make this undefined? No. So is 8 a good solution? Yes. Okay? So my solution is that y equals 8. Yeah, Kendall?
In solving the equation after you find all that stuff, can you subtract 45 from 115 and then divide both sides by 7?
You would have to subtract, well, you could divide both sides by 7 if you don't forget to include 14 when you do that. So if right here, yeah, okay, sorry. You mean before this, right? 45, that's fine. You would have gotten 70. And divide by 7 would be 10, and then subtract 2, and you would get 8. Okay? All right, any other questions about this? No? Okay, so